method as virtual work method, virtual work method, and also you can name it as unit load method. So in this method, how will you calculate the deflection and slope? According to this theorem, this is also known as the virtual work method, unit load method, and Castellano theorem. In these are based on the energy method. First of all, what is strain energy? We have discussed this in strength of material that strain energy is the energy stored in an elastic structure that when it get deformed. So the energy stored in that structure is known as strain energy. So these methods, in this method, we will be first of all calculating the strain energy stored in that structure and then applying the theorems. So according to Castellano theorem, in a structure the material is linearly elastic, Hooke's law is valid, temperature is constant, supports are unyielding. Then the deflection at any point in the direction of load P will be first partial derivative of total strain energy with respect to that force. Suppose this is the cantilever beam in which load P is acting. Suppose you have to calculate the deflection at B point. So for calculating the deflection at B point, it is the partial derivative of the strain energy with respect to that force which is given here. Okay, so you have to apply that force in the direction in which you have to calculate the deflection. So for example, in this case, the load, you have to calculate the inclined deflection, this deflection delta d here. So for that, that load is applied in that direction. So deflection at that point can be calculated by partial derivative of strain energy stored with respect to the force. And if you want to calculate the slope, so Castellano's first theorem is for deflection and second theorem is for, you can say it is for slope. For slope, where you have to calculate the slope, you have to uh, calculate by applying the partial derivative of strain energy with respect to that moment. So if this moment is given here, and you want to calculate the slope here, so for that slope is equal to partial derivative of strain energy with respect to the moment. Sign conventions that are followed in these theorems are positive deflection are taken in the direction of the force and positive slope are taken in the direction of moment. So this is the sign convention that we will follow. And strain energy uh, may be caused due to bending moment, shear force, axial force, torque. So the formula for the strain energy stored due to bending is, that is, integration of mx square dx upon 2ei, and same for shear force. This moment will be replaced by shear force here, sx square dx upon 2ag. Ar is the reduced shear area. The strain energy stored due to axial load, that is px square dx upon 2. Strain energy stored due to torque will be tx square dx upon 2g ip. Ip is the polar moment of inertia. So these are the formulas for the strain energy. So suppose we have to calculate the deflection under the load. So this is the case of a cantilever beam in which we have to calculate the deflection at the point where point load P is given. So in that case, what you will do? First of all, you will take a section here for calculating the strain energy. Suppose this is x section. This distance is x here. Now what you will do? You know that for finding the deflection, that at B point will be partial derivative of strain energy upon the load that we are talking about. Okay, so use the strain energy. So how will you calculate the strain energy? And this is the case of bending. So strain energy stored due to bending is integration. For calculating strain energy, integration mx square dx upon 2e. Okay, so this is the strain energy stored in this beam. So for calculating the moment, I have taken this section here, x section. So for this, moment will be p into x. So mx will be integration, as we have to consider the whole beam here, because we have to calculate the deflection at b point. So from 0 to L, mx will be, this is producing the moment as clockwise moment. So this is negative px. Okay, and because this moment is hogging moment, so px square upon dx upon 2ei. So now solve this equation. P square will be outside upon 2ei will be outside, and x square integration will be x cube upon 3, 0 to L. And after solving, we get P square L cube upon, which is 6ei. So this is the equation of strain energy. Now for calculating the deflection, we have to partial derivative of the strain energy. So take del u upon del p equal to L upon del p square L cube upon 6e. Okay, so you will get 2p L cube upon 6e, and you will get p L cube upon 3. So this is the value of deflection at B point due to load P. Okay, so this is how we will use the concept of Castigliano's theorem. Okay, now I will tell you the case of second case, that will say that deflection at a point where force is not active. Suppose this is the force which is given here. Now if you want, if in the numerical it says that you have to calculate the deflection at C point, so you have to consider a pseudo load here, which is imaginary load. If deflection is desired at a point where force is not applied, then pseudo load or method is used. अब अगर डिफ्लेक्शन फाइंड करना है तो डिफ्लेक्शन के लिए हमको सूडो लोड अप्लाई करना पड़ेगा उसमें. सूडो लोड मीन्स इमेजिनरी लोड. जैसे कि इस पे पॉइंट लिखा है कि से पॉइंट सी to find delta C, a pseudo load at C, say Q, in the direction of desired deflection is applied. The total strain energy caused by the given loading and pseudo load is found. So after finding out the strain energy, you have to just calculate the deflection similarly by applying the Castigliano first law. That says that deflection at C equal to the partial derivative of strain energy upon the with respect to the pseudo load, and pseudo load is tending to 0 because there is no load there. So actual deflection at point C is found by Castigliano theorem. Similarly, for calculating the pseudo load method, when you have to calculate the rotation. So for calculating the rotation, del u upon del m, where m tending to 0 because there is no moment. You have to apply a pseudo moment at that point where you have to calculate the slope. Yeah. So similarly, in case other cases you can apply the numerical. So you can try this numerical. I told that this is simply supported when carrying a point load. EI is constant in this. So first of all, you will calculate the reactions and apply the strain energy at C point if you are calculating the deflection. So for that, take a section here. Suppose I have taken a section here XX. Now the moment will be P by 2 into X, and the distance, the integration will be from 0 to L in that case. 0 to L by 2, because we have taken a section here and we are considering, we have to calculate the deformation at this point. So this will be the case that strain energy will be 0 to L by 2 P by 2 into X. dx and solve this equation, you will get the strain energy and apply the Castigliano theorem, value upon del P, you will get the value of the deflection at that point. So this is how we will try to do. Next we will be discussing numerical based on this topic. So thank you very much.